All right. Alexis, in this expression right here, what's my exponent?
Would it be 5?
No, that's the base. A logarithm is an exponent. Here's the logarithm. What's the exponent going to be?
So would it be the whole thing?
No. Don't see it yet?
No.
Okay, hang on, you'll see it. This is going to click is what's going to happen. I mean, for all of you, you know, at a certain point in time today, this is going to go, oh, I understand now. So Hema's not here. Hema's at the dentist. I don't know. Where would you rather be? At the dentist or here learning about logarithms? Tough choice. Tough choice. You notice I didn't wait for the answer. You noticed that, right? I didn't wait for the answer. I don't want to hear the answer to that. Sophie, what's the exponent going to be?
Y.
The exponent's going to be a logarithm is an exponent. So my exponent's going to be y. My base is 5 because it's telling me right there, right? And 5 to the y is equal to x. So here's another example right here. I have -1 equals log base 5 of 1/5. Well, my base is 5. My exponent is -1, and that is equal to the argument of the logarithm 1/5. And indeed, that is true, right? 5 to the -1 power is equal to 1/5. So when I do these type of problems, I actually have a little cartoon going on in my head. So if I say, let's say log base 3 of x is equal to 7, okay? And I want to solve for x. Well, I want to turn this logarithmic form into exponential form. So what I do in my head is I take this 3, which I know is the base, right? The little number at the below the logarithm is the base. And I kind of move it over to this side over here. And since that's the base, and I know this is the exponent, the 3 kind of pushes that 7 up on top of itself. So it becomes 3 to the 7th. And once this base is gone, the log kind of falls off, and all I'm left with is x is equal to 3 to the 7th. So I actually kind of have this little cartoon thing going on in my head where the 3 moves over here and it pushes the 7 up on its shoulders, you know, and I have 3 to the 7th, and that just leaves the x. All right, so let's actually do some problems here. Okay, so remember, the answer to a logarithm is an exponent. So these are all in exponential form. There is no log. If there's a logarithm, it's going to say log. So if you don't see log, there is no logarithm. Okay, so I want to change these into logarithmic form. These are exponential expressions. I can change them into logarithms. So I'm going to do this one, and then I'm going to have you guys do the next two with the magic ball. So I know that a logarithm is an exponent. I need to change these into logarithmic form. So I know that's going to have log, so I'm just going to start with log. Okay. And I know that a logarithm is an exponent. Well, the exponent in this expression right here is 8. So I know that's going to be what it's equal to. That's the exponent. Well, what's my base? Well, the 8 is sitting on a base of 5. And the only thing left is my argument, which is t. That's the only thing that's left. I already took care of the 8. I already took care of the 5. All I got left is a t. So I can say this expression and that expression, they are identical. One is in exponential form, and the other is in logarithmic form. Okay, let's try the next one. Okay, who's going to help me with this? Angie, see if you can help me with this. Okay, I want to turn this into a logarithm. What should I start with?
Well, I just started by writing log.
A very good start. And then what did you do?
And then the exponent. Oh wait, oops, I wrote it down. The exponent would be 12,
No.
or like the.
No, look, this is an exponential expression. What's the exponent in this expression?
-2. So that's, yeah.
That's going to be there. Okay.
I wrote it down like with the wrong number, so I'm a little off. But then the base would be x.
Very good.
And then 12 would be the argument.
Very good. My base is x. It's holding up the exponent of -2. And my argument is 12. How are we with this? Are we okay with this? Pretty good? Okay, I'm seeing thumbs up. That's good. Okay, let's look at the next one. Katie, can you tell me how do you change this one here into logarithmic form?
I put log and then e as the bottom one, and then 10, and then equals x.
Very good. The logarithm is the exponent. Here's my exponent. Here's my base. There's my argument. Knowing how to go back and forth, logarithmic form to exponential form, very important. And I think the next thing here, we're going to change these into exponential form. How exciting. So I'm going to look at this one here. So exponential form, I have a base and an exponent. So a logarithm is an exponent. I know my exponent is y because a logarithm is an exponent. And I know that my base is 2. So this is going to be 2 to the y power is equal to 21. Logarithmic form, exponential form. I'm going the other way now. Now this right here, this is a z. Okay, so that's log base z 12 is equal to 6. So let's see who's going to do this one. Alexis, can you do this one?
Yeah, so we would take z, and then it would be to the power of 6, which would be equal to 12.
Very good. Very good. How about the last one here? Last one here. Isa, you hear Isa?
Yeah, I'm actually like trying to figure it out. So I thought I would first do like a and then to the power of 10, but then.
Oh, okay. So you're saying on this one here. So
Yeah.
So Isa, logarithm is an exponent. What's the exponent going to be in this one here?
10.
Nope. The logarithm is the exponent. This is the logarithm. So what's the exponent going to be?
A.
A is going to be the exponent. And what is the base going to be?
Is it going to be the 2?
That's right. So 2 to the a is equal to what?
Log 10 or 10
Not,
log.
not log 10, just 10. So what's going on here is the base is going over to the other side and putting the exponent on its shoulders. So that becomes 2 to the a. And when I remove the base, the logarithm kind of disappears and all I'm left with is 10. So 2 to the a equals 10. Can you see it?
Yeah.
We're kind of okay? Yeah? Yeah, I'm seeing nods. Okay, all right. So try this one. Write it in exponential form. I would like this in exponential form. Of course, you know, I put Hema back in the bowl thinking I wouldn't call her, and then of course I called her, right? So, Hema, you're not here, are you? You're at the dentist. Okay. Sophie, you got an answer for this one?
Yes. 2 is the base, 4 is the exponent, and that's equal to 16.
And indeed, 2 to the fourth is equal to 16, isn't it? 2 to the fourth is equal to 16? Yeah, I think so. 2 to the fourth is equal to 16. Yeah. 4 times 4, 16. Good. Okay. How about this one here? If we had clickers, the confetti would be coming down and oh well. So Marissa, can you do this one?
Yeah, I got y to the power of -3 is equal to x.
That's excellent. That's right. You have a little cat on your card and your thing that looks just like, see, your cat looks very similar to my cat. I have a feeling though that you're probably a better artist than I am. That's my guess. Okay, now write this in logarithmic form. Okay, this is exponential form. Exponential form means it's got an exponent in there someplace. I would like it in logarithmic form. Angie, you got me an answer?
I think so. I got log, like the base 5,
Uh-huh.
to the power of 625 equals 4.
Yeah, that's right. We don't say to the power of 625. The way we call, the way we describe these is we say log base and then blank whatever the base is of and then whatever the argument is. So that would be log base 5 of 625 is equal to 4. Okay, you'll get used to that. That's not such a big terrible deal. Okay. All right. Oh, this one's looking a little bit like a fraction happening here. So again, logarithmic form. How do we write this in logarithmic form? Camila, you got an answer for me?
Yes. I have log base 1/7 and then 1/49 equals 2.
Yeah, I think that's right. I think that's right. Because 1/7 squared is equal to, yeah, that's good. Very good. Okay, we're kind of getting this. Pretty good with this. Yeah, good. Awesome. Wonderful. Oh, don't even have any numbers now. Okay, how do we write this in logarithmic form? No numbers, just concepts. Bridget, did you change locations in your house?
Yes, I did.
Oh, because I went from happy. So that might be why you went from the top left-hand corner down to the bottom.
Mm.
I haven't quite ever figured out, like, why do people move around on this screen? You know, I don't get it. There must be some logarithm. Algorithm, not a logarithm. There's an algorithm to that. Okay, so Tiana, you have an answer for me?
Yes.
Oh.
Log base A of
Uh-huh.
B equals C.
Log base A of B equals C. Logarithm is an exponent. Very good. Well, that's good progress. This is good. Okay, so so this is, well, first of all, we're going to stop logarithms. I do have a couple things to talk about before you go, but we're going to get out a little bit early today. Not much early, but a little bit early. Unless you want me to keep going. You guys are too much. You know that, really. Okay, couple things that I forgot to talk about. A couple lessons from the group test. So you still have, until next week to turn in your individual test, but a couple lessons. One lesson has to do with this. Hang on a second here. Yeah, this right here. Remember this? Everybody seen this? Beer and pizza. I've told the beer and pizza story, haven't I? Yes? Okay, right. Yeah. I was perfectly happy to go into the breakout rooms and help with, your understanding. One of the reasons I like to have the group quiz, which is generally a little bit lower stakes than a take home or an individual quiz, is because it's another opportunity to kind of learn. But what I was learning was that I would say a large proportion of the students in this class and the other class are not doing enough practice problems. And the reason I drew that conclusion is because both of the problems on that group test were like almost directly from the book. So I figure if you've been doing practice problems, somebody would have asked me about that one. And so I'm getting on the beer and pizza bandwagon here, ladies. I mean, like keep up with your practice problems. I'm not saying every night. I'm not saying an hour every night, but like a little bit, every night or two. And then, then what you can do is when you get stuck on one, you can come and say, Mr. Jenkins, I don't understand this practice problem. And then I explain it to you and then you get it, or I explain it in class and then you get it. So like, what I really want is I want when you're in college, I want you to be sending me an email at the end of your first semester saying, Mr. Jenkins, I'm so glad you banged my head against the wall for beer and pizza, because during finals week, I was sitting there, drinking root beer and eating pizza, and all my classmates were like sitting in the study hall or in the library, beating their head on the desk because they didn't know what the hell was going on, right? So like internalize it a little bit, beer and pizza. I'll even send you a picture if you want one, you can put it up on your wall when you're in your dorm in college, your beer and pizza picture, right? But you got to do more practice problems so that you're kind of on top of it. The second thing I want to recommend is I want to recommend that while you're doing your practice problems, you practice with Desmos. I really think you should I think you should try and use it. I mean, you may have noticed we have not been using the calculator all that much because I think for the things that we're doing in pre-calc, I think Desmos just works better, and it's a lot easier. It's a lot easier to read. You can do all these things on the calculator, but it's a lot more buttons and a lot more steps. And so, so I think Desmos is better. And, you can put Desmos on your phone. Like I've told you, you can put Desmos on your phone and take it with you when you go on a date, in case you need to do a graph. You never know when you might need a graph on a date. Your date's getting a little bit too fresh. You just pull out your phone. Hey, let's do a graph. And that kills the atmosphere instantly. I promise you. Try it. Give it a try. Better yet, don't go on a date. Forget those boys. Screw them. Forget it. They're stupid anyways. Okay, I digress. Okay, so practice Desmos, practice problems. Yeah, I think that's about it. I talked to so it was Bridget, Tiana, and who was the other one in your group? Yuleni. You guys get together and make sure that I get a copy of the test. Canvas it wouldn't upload it, so make sure I get that copy. I got a chat going on here. What's going on? Hang on a second here. Okay. So the logarithms lesson is 5.4 in the book. And I was recording it for Hema because she's not here. And as soon as it's over, I'm going to upload it to YouTube and I'll just send it out to everybody so you have it if you miss some stuff. Right. And, I'll watch it on double speed or whatever. And, if you get stuck. Sound good? Okay. Any questions? No? Okay. Then have a nice weekend. Stay safe, stay dry, and we will see you on Tuesday.
Mr. Jenkins.
Later.
So I sent you an email with the same scan from the Genius Scan app.
Great.
It might be an issue with the scan. So if you want, I can send you another email with pictures or something.
Hang on a second. I'm going to look at it right this minute.
Okay.
I already am there. Gmail. Here's the 4.6 test. No, looks great.
Okay, awesome. Thank you.
We're good. Okay, thanks, Bridget.
No
How
problem.
you doing?
I'm good. How are you?
I'm okay. You kind of pull it back together from the little detour
I
you
did.
further. Yeah.
It took a lot of work, but I pulled it back together.
Yeah. And you're still working at your job?
Yeah. Mm-hmm.
Yeah. Are you getting any more people hassling you about masks and things like that, or is that not so much?
Every once in a while, but people aren't quite as angry about it anymore. They just seem more annoyed. Back in May and the beginning of summer, they were really pissed if I asked them to put a mask on. And so now they just kind of roll their eyes and do it. So.
All right, good. And you're like an assistant manager or manager or something?
Yeah. It's shift leader is the official title, but
Good for you. Good for you. All right, great. We'll see you later.